nass wie ich. I am in the room A04. Thanks. Okay. Yes, already on.
It's okay? Yeah. Okay, yeah. Sorry for all this fuck up.
Oh, no problem.
Am besten die PDF-Version, die ist neuer. Test, Test.
Das ist zu leise. Du darfst lauter sprechen, ja?
Okay, I will try to talk very loud so you guys can hear me.
Okay, wo ist dein
That's great.
Ich sehe jetzt gerade nicht vom Namen her etwas.
Richard Summit.
Hallo? Das scrollt nicht.
This one.
Das war ja.
Okay, guys, as you can see on the slide, my name is Richard. Hello. Okay, I'll try to talk really loud right now. I want to welcome all of you to my short talk about WAF. WAF, well, it's a very short and very impressive name for a web application fingerprinter. It's written in Ruby using SQLite 3 databases for its fingerprints. And well, how does it work? It works by fetching static files from web applications. It's a bit like the one you may heard yesterday, if you attended the lightning talks yesterday, where there was a talk about fetching FAF icons and matching those checksums against the database. Well, WAF is going to fetch, or WAF fetches all static files contained within a web application, all JavaScripts, all PDFs, all HTML, XML files, and compares those checksums against the very huge database. And with the help of those matches, it calculates on what's the best match. And this way, it's also able to identify sub-releases or minor releases, or even if it's alpha 1 or alpha 2 of a software. Well, why to write a tool like that? Because there was a need for it, and of course, automatic fingerprinting is always a cool thing. We all know of that from Nmap for basic network services, or from NASes. Because we need this data if we are going to perform vulnerability assessments or some other security testing, and we are facing about 2,000 web applications at a big customer or big government or something like that, and you want to fingerprint all those versions for all different web applications from remote without access to the servers, then something like that is really cool and really easy. You just fire it up, provided all your URLs, and at the end, you will get all the versions, the products, and the sub-release versions of all web applications running there. That's an example output of all the options currently implemented. Well, it's not actual because I added some new functions tonight. Yeah, the latest stuff can be found on the website. I will show you the URL in a few seconds. No matter. This is how a standard run looks like in some kind of verbose mode. There you can see that we provided a parameter for the product because we know out of the URL, okay, it's a phpMyAdmin website. Then it's going to collect all the files, the static files, and the information about the checksums out of the database, the local fingerprinting database, and it's going to fetch all those files needed, matches those files against the database, and it has a match with 99.33% that it's phpMyAdmin 2.11.9.1, even if the installation is protected with the default authentication mechanism. Right now, there are more than 600 different versions in the database which we are able to identify. The products right now in the database are, those are placed the fav icons here, Typo3, FluxBB, Drupal, PHPBB, WordPress, and so on. That's one of the most important parts of the tool to fill the fingerprinting database. So if you are interested in something like that, or you have some spare time and you want to help in that project, I want to ask you and please you to help us to fill the database with valuable fingerprints. The most important things would be to have fingerprints of commercial content management systems or some closed source stuff. I will show you some more information later on. We can meet up after the talk. You can have a look at the website. And warning it at this point, it's still under heavy development. Even if it's working right now and it's working really good and really fast, you should not solely rely on the results of the tool right now. Yeah, we have a lot of new features planned. They are in the pipeline. You will find them on the website, new fingerprints, more documentation. I plan to put some movies online, how-to movies on how to use it. You can get it over here on the website. Really simple, straightforward, mightydy.org/web. Well, thanks a lot. That's it. Get in contact.
Eine Sache nur, wenn du so zeigst, dass er ein Objekt ist, weiß keiner, wie du zeigst. Okay.
Okay. So the next talks we will hear from Michael and Georg. So the next talk we'll be hearing from Michael and Georg about lib CPU and lib homebrew and about Yaxim. And after that we'll hear about hackable devices. So can I just see the... Oh, you're there. Good. So we just have to find the PDF on a new stick. The slides are very new, so we couldn't get them before the lightning talk session. So let's go.
Hallo? Test, Test, Test. Hallo, hallo? Okay, okay. Okay. Okay, hello. My name is Michael Steil. I'm going to talk about the libCPU binary translator, which is an LLVM-based binary translator. You might be familiar with binary translation, which is translating machine code from one machine language into another machine language. There's lots of examples nowadays. Pretty much every emulator has a translator from PowerPC M86K MIPS to mostly x86 because that's what most people use. Okay. Okay. So what all these binary translators do is they convert something from a source language into a target language. The better ones, what they do is they have some intermediate representation and they can perform some optimizations on those, but very few of those of the binary translators that exist do that. But if you look at this intermediate representation to target recompilation, this is a very well understood problem, and pretty much every compiler does exactly that. So why not just use an existing compiler, for example LLVM, for the backend of a recompiler? And that's what the project is doing. We use LLVM, which is an existing compiler infrastructure. It has a C front end, it has a static recompiler, or it can do JIT, and it has a very nice intermediate representation on disk. So libCPU is a generic anything-to-anything recompiler, and you can just use it inside your own emulator as a CPU plugin. And this is how you would use it. You create your CPU, you can create many CPUs if you like, you can set some flags, you can set where the RAM is, and then you just give it an entry point and run it. And then it will exit when there's something that it doesn't understand or something that you have to handle, like a hardware access or a system call. So this is what we have. The core has lots of reusable code, all this code that every emulator needs. So we just provide that. And what someone else has to do is just write more front ends. We have 2 front ends right now, which are working pretty well. And you can just add more front ends. What is working right now is Motorola 88K.